To solve a polynomial by factoring, there's a couple of terms that we need to discuss first. The first is the fundamental theorem of algebra, which says if you know the degree, then you know how many roots there should be. So if there's a degree of 4, meaning the highest exponent is 4, then there are 4 roots. The degree and the number of exponents should always match. Then we have the complex conjugates theorem, which says that if you have an imaginary number as a 0, then its conjugate also has to be a 0. We can use this to our advantage to remind us that there are always an even number of complex roots. So if you have an I as a solution, you should always have another I to make it an even amount. This helps remind us to put plus or minus in front of our answers so that we can get the correct number of roots and we can have an even number of imaginary or complex roots. To solve by factoring, we're going to use our same method that we had in chapter 4, where we are using A times C and listing the factors and moving down the steps. So first we check to see, can I take something out of each of these pieces? And I can't. So we'll have A times C equal -9. Factors of -9, well really we'll list the factors of +9 and we'll deal with our signs in a minute. So we have 1 and 9, 3 and 3. And the goal of factoring is for me to multiply to equal my AC value, my -9, and we want to add to be the B value, -8. So if I want to multiply to be a negative number, then I must have a positive and a negative. If I want to add to equal a negative number, then I want the larger number to be negative. So 1 and -9 would be the best solution. We'll draw our box next. And remember, we'll have the first term in the first box, and instead of a squared, it's a to the 4th power this time, but that's all right. Our last term will go in the last box. And these two numbers together will combine to equal my middle term. So they'll each need an x squared. So 1x squared and -9x squared. And it doesn't matter which order you put those in. What can I take out of the top? X squared. Out of the bottom, -9. Then out of the left side, I can take x squared. And out of the right side, I can only take a 1. These are my two factors. I'll have to set them each equal to 0 to solve and find my 4 solutions. So x squared plus 1 equals 0, and x squared minus 9 equals 0. We'll subtract 1 from both sides, and that gives us x squared equals -1. Then we need to square root both sides. And whenever you take a square root, you have to put plus or minus. This is what gives us 2 separate solutions here instead of just 1. You'll be short by half of your solutions if you forget to put your plus or minuses. A negative under the radical is I, leaving us with the square root of 1, which is 1. So 2 of my solutions are listed here, positive I and negative I. For the next one, we'll add 9 to both sides, giving us x squared equals 9. Square root both sides, and we'll have x equals plus or minus the square root of 9 is 3. So my 4 solutions are positive I, positive 3, and -3. For the next problem, We can't take something out of each of the pieces. So A times C gives me -4. The factors of 4, 1 and 4, 2 and 2. I'm trying to multiply to equal -4. I want it to add to equal 3. If I want it to multiply to be a negative, I'll have one positive and one negative for my signs. Adding to be a positive will mean the larger factor will need to be positive and the smaller one will be negative. So -1 and 4 will work. Draw in my box. First term, first box, last term, last box. -1 x squared and 4 x squared will make up my middle term. What can I take out of the top row? An x squared. Out of the bottom row, 4. The left side, x squared. The right side, -1. So we'll have x squared minus 1 that we'll need to set equal to 0. And then we'll have x squared plus 4 that we'll set equal to 0. It does not hurt, too, to double check your factors to make sure that they do indeed multiply to be the inside boxes, especially when you're taking out multiple numbers. It's always a good idea to double check. So for this side, we'll need to add 1, leaving us with x squared equals 1. Square root both sides, and x squared will equal plus, sorry, not x squared, x will equal plus or minus the square root of 1, which is just 1. For the other two roots, we'll subtract 4 from both sides. And then we'll have x squared equals -4. Square root both sides. So x will equal plus or minus. Square root of a negative means I need I, and the square root of 4 is 2. So my solutions are x equals plus or minus 1 and plus or minus 2i. 1, 2, 3, 4 solutions. The degree was 4, so I found them all. Let's take a look at what happens when there's a number in front of my degree term, or my leading coefficient is a number other than 1. We still check. I can't take something out of all three pieces. So my a times c will be -24. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 does not work, and 6 is already written. My goal was to multiply to be a -24, and we wanted to add to be -5. Multiplying to be a negative will mean I'll need to do 1 plus, 1 minus. Adding to be a negative will mean that the larger factor will be negative. The only factor set that works is 3 and -8. Into our box it goes. We have 6x to the 4th, first term, first box. Last term, last box, -4. And then 3x squared and -8x squared. What can I take out of the top? I can take a 3 and an x squared. Out of the bottom, I can take a -4. The left side, I can take a 2 and an x squared. And then the right side, 1 is the only thing common. So my two factors will need to set equal to 0. We'll have 2x squared plus 1 equals 0, and then 3x squared minus 4 equals 0. Subtract 1 from both sides here, and we'll have 2x squared equals -1. Divide by 2 on both sides to give us x squared equals -1/2. Now is when we'll square root both sides. This is really kind of putting it all together from what we learned in chapter 4. We had factoring and we had solving by square roots. Now they're combined together to solve a single problem. So plus or minus goes in front when we square root. A negative comes out as I. And when we have a fraction, we don't write this as 0.5 and we don't type it into our calculator like this. We'll take the square root of the top, 1, over the square root of the bottom, which is just square root of 2. We should rationalize this denominator like you learned in geometry with Pythagorean theorem and with special right triangles. And remember, to rationalize the denominator, you'll need to multiply the top and the bottom by the square root of 2. So x will equal plus or minus 1 times the square root of 2, which is just square root of 2, and the square root of 2 times the square root of 2, which is just 2, and then I. You won't always have to rationalize the denominator. You only need to do that when you have a radical in the denominator. Over here, we will add 4 to both sides, which gives us 3x squared equals 4. Divide by 3 on both sides, and we'll have x squared equals 4/3. Finally, we'll need to square root both sides, and we'll get x is equal to plus or minus the square root of the top, which is 2, and the square root of the bottom, which is the square root of 3. We've got to rationalize that denominator again, so we're going to multiply by the square root of 3 on the top and the bottom, and that will give us that x is equal to plus or minus 2 times the square root of 3. Nothing we can do, it's going to stay exactly like that. And then the square root of 3 times the square root of 3, which is just 3. So my solutions are x equals plus or minus the square root of 2 over 2 I, and plus or minus 2 square roots of 3 over 3. Last problem for our notes. We check to see, can I take something out of all of the pieces? And I can't, so a times c, -24 again. Factors include 1 and 24, 2 and 12, 3 and 8, 4 and 6. We are trying to multiply to be that -24, but we're trying to add this time to equal 10. Multiplying to be a negative will mean I need 1 plus 1 minus. Adding to be a positive will mean the larger number will be positive, and the smaller one will be negative. So -2 and 12 work. We'll draw our box. First term, first box. Last term, last box. Negative 2x squared and 12x squared make up our final two boxes. I can take a 2x squared out of the top, and on the bottom I can take a 3. The left side I can take 4x squared, and the right side I can take a negative 1. Again, it's not going to hurt to just double check that your outsides equal your insides. And as long as they do, you can go ahead and set your two factors equal to 0. 4x squared minus 1 equals 0, and 2x squared plus 3 equals 0. We'll add 1 to both sides, giving us 4x squared equals 1. Divide by 4 on both sides, so that x squared equals 1/4. Then we'll square root. Goal is always to get that x squared alone first before you square root, giving you plus or minus the square root of 1, which is 1, the square root of 4, which is 2. So plus or minus 1/2. For our other two factors, we'll subtract 3 from both sides, giving us 2x squared equals negative 3. Divide by 2 on both sides, so x squared equals negative 3/2. Now we'll square root both sides, so x will equal plus or minus the square root of negative, which is I, and then square root of 3 for the top, square root of 2 on the bottom. I cannot have the square root of 2 on the bottom, so I have to rationalize. So we'll multiply by the square root of 2 on top and bottom, which will get rid of my square root. So x is equal to plus or minus the square root of 2 times the square root of 3 gives me the square root of 6. They're both under the radical, so they can be multiplied like that. Square root of 2 times the square root of 2 is just 2. And no, you can't reduce this. We'll end up right where we were. So my final solutions are x equals positive and negative 1/2, and plus or minus the square root of 6 over 2i.